Hi, this is Mrs. Sigala, and this is your review that you take home with you as homework due before on the day of your test. And so here we're given some chemical formulas, and then first we have to identify them as covalent, ionic, polyatomic transition, or as an acid. And so the easiest ones for me to identify are acids, so I'm going to start with that, and I'm going to go ahead and highlight those. And so we know that all acids begin with a hydrogen, so right away I see my first acid right over here. Okay, keep looking for more H's at the beginning. Here's another one, and we have two more. So I'm going to go ahead and identify those as acids. And if I skip one, I'm sure I'll find it and I'll come back and get it. Alright, there we go. Now, after I do that, I like to identify my acids as either binary or ternary. And that way I know, are we going to start with the prefix hydro or not? So this number 11 has two elements, so right away I know it's binary. 19 also has two elements, so it's binary. 20 has three elements, so right away I know it's ternary. 23, ternary, and 25 is also ternary. Alright, so here in this review I've also included the periodic table of elements in addition to the polyatomic ions, and so we'll be referencing those two along the way. So first off we have number 11, which is binary. And so we know that all binary acids begin with the prefix hydro. So now I join hydro. Okay, and so it's up to you on how you choose to do this. So then hydro, and then we use the root part of the formula, okay, and it's bromine, so I'm going to use bromic. We ended up bromic, and we're going to end it in acid. Make sure you don't forget the ending ic. Next, 19, we have again binary, so you're going to start with the prefix hydro, and this is chloric acid. Sorry, I'm running out of space here. Next we have ternary acids, and we know that ternary acids, we wrote the little sentence, I ate an icky. White mouse. Which means that our polyatomic ion's name in this case will be changing from ate to ic. If our polyatomic ion suffix ends in ite, we'll be changing it to ous. And for ternary acids, remember all we're doing is changing that ending, that suffix, and then we're just using the word acid. So we're going to look at the first ternary acid, and here we have hydrogen, so we know it's an acid, and then we have SO4. We look for SO4 on a polyatomic ion list. Here's SO4. So SO4's name is sulfate. It ends with ate, so in this case that means I'm going to change that ate to ic. So it's going to be sulfuric. And I'm going to end it with the word acid. That's it. Next one, I have HNO2. So I'm going to look for NO2 on my polyatomic ion list, and here it is. It ends with ite, so that means I'm going to change that ending to ous. So here it's going to be nitrous acid. Alright, next one. Oh, it's the same one as number 20. Again, it's SO4, it ends in ate, so that should be sulfuric acid. Okay, so I got all my acids out of the way, and again I group them just so that way I stay in the same frame of mind. So next, what I like to identify are my polyatomic ions. So my polyatomic ions, again, poly means many. I'm going to identify them in two ways. Okay, so I'm going to have the regular polyatomic ion, and I'm also going to have the polyatomic ions that involve a transition metal. So I identify polyatomic ions right away because again they have three or more elements. So here we have for sure polyatomic. Here's 1, 2, 3. polyatomic. 1, 2, 3. So 14 is polyatomic. 15 is also polyatomic. 18 is polyatomic. 22, polyatomic. Okay, and that's it for polyatomic ions. So now what I need to make sure is that where's my metal being found? Okay, where's the cation, where's the anion? I know that the majority of my polyatomic ions, with the exception of ammonium, are all anions because they all have this negative charge. Okay, all of them are, except for ammonium. And so, in this case, you have to remember that the name of the polyatomic ion never changes. So now let's see what they're paired up with. If we look in group 1 and 2 of our periodic table of elements, okay, we know that the oxidation numbers for these groups, in addition to aluminum, okay, those oxidation numbers never change. So we have group 1 as +1, group 2 as +2, 13 as +3. Okay, so I'm going to go ahead and include all of the metals that aren't part of group 3 through 12. Okay, so all these right here. Now, some of you, your teachers taught you that everything except for aluminum over in group 13 through 15 are also considered transition metals. Okay, and we'll use the we'll figure it out when we get to from the name to the formula, but it shouldn't affect us in this case. So first we look at barium cyanide, and we see that barium, here's barium, so we're not dealing with a transition metal. So I'm just going to put polyatomic and ionic, so I don't have to worry about any Roman numeral being present. Again, I look for potassium, for K. Here it is in group 1, so that's regular ionic. Okay, sodium in NaSO4, here it is, so it's regular ionic. Copper, however, copper can be found here in this area. So here we have our transition metals. Okay, so again, our transition metals, group 3 through 12. Okay, and if you look closely, copper, here's copper. So here we do have a transition metal. So I'm going to go ahead and identify this as polyatomic, yes, but it's also combined with the transition metal. So my name, once I come up with the name, it should definitely have that Roman numeral. Okay, next polyatomic ion, I see iron. Again, Fe, here it is in group 8. It's also transition metal. So I'm going to identify this as a polyatomic and transition. And last one, we have calcium and sulfates. I look for calcium. Calcium's in group 2. So it's a regular polyatomic ion. So I'm going to put an I, and that way I know that I don't have to deal with that Roman numeral. Okay, so first we know that the polyatomic ion rules are that the polyatomic ion's name never changes. So again, here we have it combined with the metal. So first we write down our metal, which is barium. And if I look at Cn over in my polyatomic ion list, I see that the name is cyanide. So I just write down cyanide, barium cyanide. Next, I have KOH. I look for OH. Here's OH. And the name of my polyatomic is hydroxide. So this would be potassium hydroxide. Sorry, guys. Okay. Next, we have NaSO4. I look for SO4. Here it is again. It's sulfates. And I know that the Ca is calcium. So this would be calcium sulfates. Alright, and that's it for my, oh, sorry. Sorry, I was supposed to do sodium sulfate. So here's sodium again. And this is sulfate. Okay, so I got all my polyatomic ions that are regular. Now I'm going to look at the transition metals. And so for this one, we do have to do a little bit of math. And so if I look at my polyatomic ion here, I see PO4. I'm going to look for that on my list over here. So here's PO4. I look at the oxidation number. For one PO4, because remember that's going to stay together, the charge is -3. So I'm going to write that down. I'm going to erase this real quick. I'm going to write that down below it. I have two PO4s. So again, the second half of this molecule, because there's the charge for each PO4 is -3, and I have two of those, the charge for the second half is going to be -6. The first half is +6. Now I need to find out the oxidation number for every single copper atom. We have 3 copper atoms, and the 3 of them combined have a charge of +3, so that means that every single one has a charge of +2. This is the number that I'll be using for my Roman numeral. So again, you write out your metal, which is copper. Copper 2. And again, the name of my polyatomic ion does not change, and it's going to remain as phosphate. Okay. Alright, so then we also have our other transition metal, which is already here. And we look for CrO4, which is right here. And CrO4 has a charge of -2. So I'm going to write down -2 below it. Okay, so here I have -2. Now, I put parentheses on here to remind myself that, again, if there's nothing behind that parentheses, there's only 1. So this second half of this molecule has an overall charge of -2. In order to balance it out, this has to be a +2. We only have 1 iron atom, so each iron atom has a charge of +2. So in this case, I'm going to write down iron 2, and I'm going to write my polyatomic ion, which is chromate. Is that what it is, CrO4? Yes, chromate. Alright, so then next I like to look at my other compounds, okay, and they should all have only 2 elements in them. So now we have to differentiate between covalent, ionic, or if it involves a transition metal, because we already got all of our polyatomics, we already got all of our acids, but we still haven't identified those binary compounds. So again, I have to look for these on my periodic table of elements. And so I'm going to look for SR. SR is in group 2. So it's going to be ionic. Let me change this color to green. Okay. K, again, it's in group 1, so it's ionic. Okay. PF, I look for phosphorus and for fluorine, and if I find them, they are all in group. Here's phosphorus. Here's fluorine, so it's 2 nonmetals, automatically that's covalent. Nitrogen and oxygen are both nonmetals, that's covalent. Phosphorus and fluorine, again, covalent. Next, I have cobalt and iodine, so look for CO. CO is right over here, so that would be transition. Okay, so we put this a T for transition. CR, if I look for CR, there you go, and it's also transition. I look for aluminum. Aluminum's over here, so that makes it ionic. I look for iron. We just used iron earlier, so iron is over here in group 8. So again, that's going to be transition. I look for K. K is in group 1. It's regular ionic. Ca is in group 2, regular ionic. Ci, carbon and iodine, these are composed of both nonmetals, so in this case would be considered covalent. Fe, again, Fe is in group 8, so it's transition. Then we have NO2, nitrogen and oxygen are both nonmetals, so this one would be covalent. Alright, so then from here we kind of just work on them in order. Okay, so again, the only ones that I know right away, because of the prefix, is going to be my covalent compounds. So again, covalent compounds, you write out the first element, and then the second element must end in IDE, and then you use the correct prefix for based on the subscript given. We never use mono for the first element, but we do use di, tri, tetra, and so forth. So here we only have one phosphorus, so we will start off with phosphorus. We have 5. Let me see if I can make this bigger. Make it smaller. So here we have phosphorus. We have 5, so we're going to start off with penta. We have 5 fluorines, so it's going to be pentafluor. And it's going to end in IDE. Phosphorus pentafluoride. Okay, next we have N2, so this would be dinitrogen because there's 2. There's only 1 oxygen, so here we do use the prefix mono. So it would be monoxide. Okay, next we have 4 phosphoruses, so it would be tetraphosphorus. We have 10 fluorides, so it would be decafluoride, and end in IDE. Okay, we have one more covalent. Oh, I'm sorry, we have 2 more. So number 17, we have carbon. There's only 1, so we don't use a prefix because it's the first element, so it's carbon. And then we have 4 iodines, so it would be tetra. Oops. Iode, and then ended in IDE. Okay. Our last one, you have nitrogen and 2 oxygens, so here would be nitrogen dioxide. The next ones that are fairly easy for me to answer are the ionic compounds. And again, because the rules for ionic compounds, first you list your metal, then you list your non-metal or your anion, but you want to end the anion with the ending or the suffix IDE. Okay, so again, number 1, my metal's name is strontium. My non-metal is phosphorus, so here I'm going to end it with phosphide. And let me do with these ionic compounds what I did with my covalent compounds. It's going to be strontium and phosphide. Next we have potassium. Okay, a lot of my students have been putting P. P is for phosphorus, not potassium. Then we have iodide. Next ionic compound, we have aluminum. And sulfide. Next we have potassium, but we have 2 potassiums. And so I'm going to make sure that I put, oh, I'm sorry, no, we don't, it doesn't matter how many potassiums we have. I just list my metal. I almost confused myself. Potassium with oxygen, so it's oxide. Okay, next we have calcium. And again, your non-metal would be bromine, but it has to end with IDE, so it's bromide. And that's it for ionic compounds. So next we have transition metals. And so again, remember, all transition metals will have those Roman numerals. Okay, so we have to figure them out. So iodine, we know iodine's oxidation number, which is -1. We have 2 iodines, so this is -2, which means that the first half of this formula has to be +2. We only have 1 cobalt, so each cobalt has a charge of +2. So here would be cobalt 2 and then iodide. We have to make sure that we end it with following ionic rules, which means have the suffix IDE. Next, we have chromium and oxygen. So we know oxygen's oxidation charge is -2. We have 3 oxygens, so this has a charge of -6. The first half, in order to balance out that -6, has to be +6. We have 2 chromiums. So that's going to be, each chromium has a charge of +3, because you take +6 divided by 2 and end up with +3. So my name is going to be chromium 3. I'm going to have to split it up a little bit. And then oxide. Okay, last one, we have iron. We don't know iron's oxidation number, that's what we're looking for, but we do know chlorines. Chlorine has an oxidation charge of 1. There's 3 chlorines, so there's -3. Has to be +3 in order to balance out that -3. There's only 1 iron atom, so each iron atom has a charge of +3. So here, my name would be iron 3 chloride. Alright, so that's it for that. Next, we're going to move on to going from the name to writing the chemical formula. Okay, so now you have to be able to identify these, and the ones that are, again, easiest for us to identify. In this case, I like to start off with my transition metals, because, no, you know what, I'm going to start with acids, because acids, again, they're all going to end with the word acid. So I know number 1 is an acid, 6, 12, and I'm needing a little bit of space because right now I like to identify whether I'm dealing with a binary or ternary acid. And here we go. Alright, so if you remember the rules from binary, all binary acids will begin with the prefix hydro. So I'm going to look to my acids, and here we have binary. My first acid doesn't have hydro, so automatically I know it's a ternary acid. 12 starts with hydro, so it's binary. Again, 14 doesn't, so it's ternary. And chromic acid, there's no hydro, so it's ternary. Alright, next, what's easy for me to identify are those covalent compounds because, again, they give me those prefixes. So I'm going to look for mono, di, tri, and so forth. So here I have bromine penta, so I know that's going to be covalent. Tetradecoxide, again, covalent. Phosphorus trichloride, covalent. Carbon tetrachloride, covalent. And we have tricarbon octafluoride. Octa. So if you notice, we have the boxes or blacked out for cations and ions because this is the only time that we will not be using that crisscross method. Okay? Because again, we know how many elements are in each one because of the prefix. So let's start off with that one. Let's start with covalent compounds. Oh, well, let's identify everything else then. Alright, after that, I know we can identify our transition metals, okay? But we have to be careful because we're not sure if this transition name, or this transition metal's name ends up being with one other nonmetal or if it involves a polyatomic ion. So I'm going to leave a little bit of space. So here I have tin-3. Because of this Roman numeral, I know it's transition. Again, transition, 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 and that's it. Okay. Next, I can identify some of my polyatomic ions because these polyatomic ions, their names will never change. And if you look at your polyatomic ions, typically they're going to end with ATE or ITE. The only exceptions are hydroxide, cyanide, and ammonium. And so I'm going to go through those, and based on the name, I'm going to identify them. Okay, so let's see. So rubidium selenide, nope. Phosphate, yes, that's definitely polyatomic. Iodide, no. Fluoride, no. Selenide, no. Perchlorate, yes, that's polyatomic. Here's chlorate, acetate, nitrate. Those are all polyatomic. Okay. So the rest I know are going to be ionic because, again, they end with IDE, and they don't have that Roman numeral to identify them as a transition metal. So I'm going to identify those. So here we have ionic because it involves a metal and a nonmetal. And that metal is either in group 1, 2, or 13. And rubidium bromide. Okay, so now let's answer our covalent compounds first, since we know exactly what they need. So here they're asking us to give the chemical formula for bromine, and for bromine my symbol is Br. And then they give us pentafluoride. So we know it's fluorine. Because of penta, we know there's 5 fluorines. Next, I have tetraarsenic. Okay, we have As. Tetra means 4. And then there's deca, decoxide. Deca means 10. So you have oxygen, and we have 10 of those. Next, we have phosphorus trichloride. There's no prefix in front of phosphorus, so we know it's 1. But then there's chlorine, and it says trichloride, so it's 3. Next, we have carbon tetrachloride. So here we have carbon. Tetra means 4. Okay, so make sure that you remember your prefixes. Okay, mono, di, tri, and so forth. All right, so we finished with those. Next, let's start with acids. And so remember, for everything else, we do have to know we have to be able to identify the cation and the anion. And so let's identify that first. And we know that the cation will always be listed first. Remember, the cation, it will always be the metal. The only exception is hydrogen because it's over here in group 1. But still, it's still treated as a cation. So again, for all acids, we know the cation will always be hydrogen. So I'm going to write that down for my acids. So we know it's hydrogen, hydrogen, hydrogen. And that hydrogen, has a charge of +1. +1, +1, hydrogen, +1. All right, now I'm going to look for my anion, or whatever it is, my nonmetal or my polyatomic ion, that has a negative charge. So in this case, it's ternary, so I'm going to look for, because it ends in ic, we know that the original suffix was H, so I'm going to look for carbonate. Here we go. So here's my anion. My anion will be CO3 with a charge of -2. Okay, next I go to hydrobromic acid. Again, that's binary. So bromine, that's Br. I look for bromine. Bromine is in group 17. So it has a charge of -1. Okay. Again, I have hydroselenic, so I know my symbol for that is Se. Selenium is found in group 16, so I know it has an oxidation charge of -2. Then I have nitric acid. Again, it ends in IC, so the original polyatomic ion ends in ATE. So here is nitrate. To be NO3. Oh, and I forgot to write this hydrogen. And that nitrate has a charge of -1. Next, I have chromic acid. Chromic, again, 8. Here's chromate. CrO4 with a charge of -2. Alright, so my next step, I'm going to be using the crisscross method with those oxidation charges. So again, this 3 goes in front of my hydrogen, this one goes in front of my CO3, so my formula is H2CO3. When these are different colors, you can see this a little bit better. This one goes in front of here, so my formula will be HBr. We don't have to write them down because, again, they're ones. So again, I'm going to do the crisscross. So it's H2SE. crisscross. I have HNO3. Okay, crisscross. I have H2CrO4 because I only have one chromate polyatomic ion. Alright, so next, we've already answered all of our covalents and all of our acids. Next, let's go work with our ionic compounds. Okay, so rubidium Rb is found in group 1, so it has a charge of +1. And again, it's bonded to selenium, Se, and selenium is in group 16, so it has a charge of -2. Again, we're going to do the crisscross method, so my formula would be Rb2Se. My next ionic compound, I have magnesium, Mg. Magnesium is found in group 2, so it has an oxidation number of +2. Iodine has a charge of -1. I'm going to crisscross, so it's Mg, I2. I have strontium fluoride, Sr. Strontium is found in group 2, so it's +2. Fluoride has a charge of -1. I'm going to crisscross, so my formula is SrF2. Okay, next I have cesium selenide, Ce. Cesium is found in group, oops, sorry, that's wrong. It would be Cs. It's in group 1. So Cs has a charge of +1. Selenium is in group 16, -2. We crisscross, it'd be Cs2 Se. Next we have rubidium bromide. Rubidium, again, is in group 1. So rubidium has an oxidation charge of +1. Bromine is in group 17. So it has a charge of -1. We crisscross, since they're both 1s, we don't need them in our formula, just be Rb, Br. Alright, and that's it for ionic compounds. Next, let's work on our polyatomic ions, okay? So next, they're regular polyatomics, and so we look at, they're going to involve a metal that's either in group 1, 2, or over in this section over here, okay? Alright, so then we take our cation. In this case, it's calcium. Calcium has a charge of +2. And now I'm going to look at my polyatomic ion, which is phosphate. Phosphate is PO4. And phosphate has an oxidation charge of -3. Oops, sorry. So if we look at phosphate on our list of polyatomic ions, here it is. So we're going to write down our anion, which is -3. And again, remember, I always like to include my phosphate in parentheses. Next, I'm going to crisscross. I'm going to put this one in a different color so you can see the crisscross. So that 3 is going to go in front of my calcium. So now it's Ca3, next parentheses, PO4, and I ended up with 2 of those. Okay, let's look at the next one. Again, magnesium has a charge of +2 because it's in group 2. Perchlorate, if I look for perchlorate, ClO4 with a charge of -1. We're going to crisscross those. Okay, so I'm going to write Mg, parentheses, because I'm going to end up with more than one of these polyatomic ions, and then 2. Next one, lithium chlorate. Lithium is in group 1. So, I'm sorry, has a charge of +1. Chlorate, ClO3, has a charge of -1. Okay, and they're both 1s. I crisscross them. So end up with LiClO3. Next, add calcium nitrate, again, Ca plus 2. Nitrate is NO3. And nitrate has a charge of -1. Okay, again, I'm going to put this in parentheses. I'm going to crisscross, so my formula will be Ca, NO3, and that 2 that came from calcium will go behind the parentheses. Looks like I forgot one over here, I skipped it, sorry. We have potassium acetate. Potassium, again, is in group 1, plus 1. We look for acetate over on our list. Here's acetate, C2H3O2. C2H3O2. And that has a charge of -1. Again, we crisscross them. They're both 1, so we end up with K, C2H3O2. Right, next we have our transition metals. Okay, next we have transition metals. We have tin 2-chloride. And again, remember that this Roman numeral tells us the oxidation number for tin. And so tin, my formula for tin is SN. Oops, let me get a different color. It's a metal, so it has a charge of +2. Chlorine has a charge of -1. So my formula, again, I'm going to crisscross. So my formula is SnCl2. Alright, next we have lead. Okay, so lead, in this case, has an oxidation number of +2. Nitrites, that's going to involve a polyatomic ion, and I forgot to identify that earlier. So nitrites, NO2. Nitrite, if I find it on my list, has a charge of -1. In parentheses, I'm going to do the crisscross. So my formula is Pb NO2, and because lead was 2, this 2 comes outside the parentheses. Alright, next one. Okay, I have gold. 1, so it's Au plus 1. Chlorine is -1. I'm going to crisscross, so my formula would be AuCl. Next we have lead 4 iodide, so Pb, and then iodine is -1. We crisscross, so we end up with PbI subscript of 4. Last one, we have tin 4, so it's Sn plus 4. Oxide, which is oxygen, -2. We crisscross. We end up with SN2O4. But again, we can reduce these right here. So my formula would be SN. Oh, it looks like I forgot a covalent compound. So here I have tricarbon, so I would have 3 carbons. Octa, fluoride. Octa means 8. And it looks like that's it.